Thanks everyone for coming out tonight. Where tonight's speaker, normally I'd go and do the news first and then do things and then introduce our speaker. However, our speaker finds himself this month in Mexico, so it's about 1:30 a.m. at the moment. So what I'm going to do is actually just jump straight into introducing Andres Almiray. Andres is a Java champion. He's been a committer to lots of open source Java and Groovy projects. Most notably, he's done things like the Griffon framework, which is a sort of think a Grails-like app for building desktop apps. He's also the author of the book that goes with it, Griffon in Action. And he's basically also one of the founders of the Hacker Garden movement. It's basically a series of hack sessions on open source projects that he runs throughout Europe and wherever meetups or conferences that he goes to. So we're super lucky to have him today. Let me stop sharing the screen. Andres, I think we can see you there. Say hello to everyone.
Hello, everyone. Hey, I can hear myself as well.
Okay. Let me see. That's switched off. All right. We'll see how we go. I can play around with the audio if it's too noisy. All right. So, yeah, when you're ready to start, you're more than welcome. It's great to have you actually present at MelbJVM.
Thank you very much for that introduction, and thank you everybody else for joining. And I'm quite excited because the topic that I'm going to present today to you, it's been presented in the past to other audiences, but they always react in such a way that I will expect some questions from you. And please feel free to raise your questions at any time. When you have them, I'll do my best to answer them as quickly as possible. We may have some time later at the end of the session as well, in case that you have any follow-up questions. So without any further ado, I'm going to share the screen, and let's start with the slides. So here we go. And hopefully by this time, the slides should be showing.
Yep, we can see them.
Excellent. Great. All right. So you saw on the on information of the meetup that the other topic is Java libraries you can't afford to miss. And now, what I want to do today is to showcase a series of Java projects that I have found in the past 5 to 10 years or so that I've been using constantly in many projects, both commercial and open source. And these kind of projects allow me to be more productive, allow me to be quicker, and to do things in a much smarter and sometimes even in a much funner way, so that you can actually enjoy what you're doing. And this is precisely what I want you to do this, to have this kind of the same experience. If you find something in your current projects with your current customers that is probably not going as well as you expected, and if you think that there's something that can be done in a much faster way, a quicker way, perhaps one of these projects will be the one that will give you the answer. Okay, so I got a use case for you, and I'm going to showcase a desktop application just because I'm a fan of desktop Java. But most of the libraries, if not all of them, you can also use them in different environments. You can use it on the server side, you can use it on mobile, or you can use it pretty much anywhere where Java is available. So the idea is to write an application that can consume a REST API, just because the REST APIs are pretty much everywhere. And we have to deal with them in one way or another. We would like to build components that are small and reusable. And we will also like to say no to boilerplate code. We don't want to repeat ourselves. We like to find a way to have our code to be expressive and not so much verbose, even though this will be using the Java language. And of course, the behavior should be easy to test. So these are the libraries that I'm going to see today, and I will expect some of you are already familiar with one of these libraries, so these names might be new to you. And I have separated the libraries in both production and test. Now, those that have a vertical bar means that you can use one or the other, that you can use them pretty much interchangeably. and that the others will actually try to fit in a specific category. Okay. So disclaimer, everything that we're going to see today is open source. You can use it immediately on your projects as long as you abide to the terms of the licenses. Most of the licenses that we'll see today are, or actually most of the projects are either Apache or BSD, which means you can use them safely in a commercial setting if you need them to. My goal at the end of the session is that you feel something like this, that I have showed you something that surprised you, and perhaps you would like to give it a try immediately on your next day when you go back to work tomorrow. All right, so my name is Almiray. I'm from Mexico, and as Con said, I'm currently streaming from Mexico, where it's a little bit past 1 in the morning. I work for a Swiss company called Canoe, and we do a lot of interesting things with Java and Groovy. And based on the experiences that I had in past years working with Canoe and working on open source projects is where this talk came to be. As Colin also mentioned, I'm one of the co-founders of the Hackagotten community. The Hackagotten community is a group of people that come together at the end of a working day, and we sit together and hack for, I don't know, for 4 or 5 hours. And what we want to do is contribute back to a person's project of our choosing. So every time that we meet once a month, we throw our ideas on what kind of project we would like to work on. Maybe it's fixing a bug, or it's adding a new feature, or it's recording a podcast, or doing something that benefits a specific open source projects. And we try to do this everywhere where we go. I'm a Java champion, a Java 1 rockstar, so that means that I know a little bit of things about Java. This year, I'm happy to say I'm now part of the JCP Executive Committee, which will allow me to help even further keep Java moving forward. So it's my goal to be close to everybody that would like to listen, and especially to Java user groups, so that if you have any questions on how the JCP works, or there's something that you would like to see going on in the future of Java, then please talk to me. I will be very, very happy to hear what ideas you have. Okay, so now let's get back, and I'm going to show you the application. The application that I based is using the GitHub API, just because it is well documented and it's quite ubiquitous. It's most very likely that you have encountered GitHub in one way or another. If you follow that URL, is where you can find the whole description of everything that is related to the current version of the GitHub API. And for now, because API is quite big, there's a lot of operations, we like to center ourselves only in query repositories. When you browse to the GitHub API documentation and you find this URL, this is where it tells you what kind of inputs you need in order to query for a repository, and what kind of outputs you get and in which formats. Basically, you issue a get call, like what you see in that pattern where organization, you will substitute it with the name of organization or a valid one, and then you get a JSON payload in certain formats with certain properties. The JSON payload looks like this. It's actually much, much bigger. There are like 40 or more properties related to a specific repository. What we have here is a list of objects, and each object represents a repository. Pay special attention to the naming convention that is used here. It's very common in the JavaScript world to use a snake cake convention to separate words, for example, full name and HTML URL, whereas in Java, we like to use camel cake convention. So when we will have to do the mapping within the JSON world or JavaScript world into Java, we also have to take into account this kind of mapping, and there's an easy way to make this happen. For this, we're going to need some kind of dependency injection. We need an HTTP client on which we can invoke REST behavior. We need to map JSON objects into Java. We need a way to reduce the boilerplate code and make sure that our code is not so much verbose. And because it's a desktop application, we have to handle concurrency. Because some of you may have experience working with perhaps JavaFX or with Swing on SWT. We know there is one very specific rule that must be followed. Everything that is UI related, that means reading a property for a widget, a text field, or writing to a text field, or painting on the screen, has to be done on a specific thread, the application event thread in the case of JavaFX, or the Swing dispatch, or the event dispatch thread in the case of Swing. Everything that is not UI related, such as reading from the file or doing a query to a database, or in our case, issuing a network call, must happen outside of the event dispatch thread or the UI thread. So at least we have to deal with two different threads. That means we need to handle concurrency in one way. So the code that you're going to see today is actually available as an open source project. Here is the URL. If you browse to this repository, you're going to find different versions of the same application. Why? Because I decided to go with different combinations of all the frameworks or libraries that we saw earlier, and that allow me to show you what with the similarities and the differences if you happen to go with one version of libraries or the other competitor or the other particular project that can give you similar capabilities. So I'm going to switch to the terminal, and I'm going to show you the first version of the application that will do this. The GitHub API allows you to query pretty much all of its operations in a paginated way. The first version that we're going to see here only displays the first page of hits. So if we say, for example, we're going to query a repository such as Griffon Legacy, which I know has a lot of elements, has more than one page worth of repositories. GitHub paginates by default 30 elements per page. And if I click load, this will issue a network call. You will see briefly a progress bar appearing on this empty space. Why is that there? Because if the progress bar is moving, that means that the UI thread is not blocked and that we are actually issuing the network call in a background. And there we go. It was quite fast. And now we see in this area that we got a list of repositories. This is just the first page. I can go to another version of the application. Let's go to version 5 and run it. This one is paginated. You will see that the UI looks a little bit different. Now I can say a limit how many different repositories. I can cancel the operation. I can give it the same name as before, same repository. And this should load about 200 or more repositories. More entries. Those are a lot of repositories. I can give a different number, for example, 45, that would be 1.5 pages. Or I can simply say 0 again, and then cancel at any time I want to. And there we go. So you see the UI is still responsive, and this is quite the simple application that we want to build. Questions so far?
Questions? Any thoughts on? That's nuts. Yep, keep going.
Okay, here we go. So I will suspect that most of you are familiar with dependency injection, and it's pretty much the end of 2017. And I think that building an application, at least medium-sized to a big one, and especially in the enterprise, without using dependency injection would be a foolish errand. And basically, what we want to do is we define contracts. So you could define it using an interface. You can define contracts directly using a concrete class if you want to. And I decided to mark in red here this type, because this is the type, this is the return type of the thing that we want to inject. But this type will come handy in a couple of slides. So basically, we define a contract of a GitHub object. This kind of like a service object. You give it a name, and it returns with something that looks like a promise that returns a collection of repositories. Now, we want to inject this thing into a component. And the application that you saw is written using the MVC pattern. So we're going to have a model, a view, and a controller. The service should be injected in a controller because the controller is the one that has the logic. So it could look like this. Now, there are 3 ways that you can do dependency injection. You can do it in this way, which is field injection. This is my preference, and I know that some people don't like it. The second preference that other people do like a lot is to use construction injection, because if you do that, then you can define your fields as final values, and you can set up all the dependencies immediately when you create the instance. But if you happen to have more than 4 or 5 arguments in your constructor that has injection, it may be the case that your current component, the class, may be doing too many things. So once you pass the 6th argument in the constructor, you will definitely encourage you to do some kind of refactoring session of that class. And the final thing will be to use a setter injection. This is perhaps the most harmful because you can set dependencies at any time. And if your class does not react to changes at runtime, if you change one of these dependencies, then that might be a problem. So, but regardless of which version of dependency injection you choose, what we want to do is inject something, some kind of collaborator in our component, and then just consume it. For this, the easiest and the quick way that we can do it is to use Juice, because Juice happens to be the dependency injection mechanism that is the reference implementation of the JSR 330. This is the one that defines how it standardizes the APIs for doing injection in Java SE, and it then follows up in Java EE with CDI. With Juice, you can define a series of bindings. For example, the first binding that we see here from a source type could be an interface, the GitHub services that we saw earlier, to a target type. In this case, the GitHub import, this has to be a concrete class. And then we bind it to a specific scope, singleton. It could be prototype. If you're on a web application, it could be conversation scope of application or session or some other kind of a scope that makes sense for your application. You may also do the second kind of binding where the source and the target type are exactly the same. And then the third type, the GitHub API is another interface, but then we bind it to something that says it's some kind of provider. Providers in Juice are a way for you to define lazily computed values. If you're familiar with the Spring, this is the same as using a factory bean. And there are a few other kind of bindings, but this is pretty much what we have. Now, the advantage of using Juice is that it's quite small. It is a reference implementation of JSR 330. It allows you to compute lazily related instances with providers, and it has an extensible life cycle. If you happen to use Juice, then you have a bonus. And that bonus happens to be the Guava library, which is also quite popular in many projects with many developers. Now, Guava was born at a time where we had some missing collections, I would say, in the standard Java library. So you have access to something called like multiset or a bimap. A bimap is a kind of map that you have a key that relates to a value, but if you want to know which value relates to a key, then you got the bidirectional mapping on backwards instead of forwards. The multi-map is a way for you to have a list of values associated with a key, but you don't have to manually manage the list. The table is kind of like a SQL table in case that you have two keys mapping to a specific value in a row. And you have other collections. You have utility classes for collections, a string, testing, caches, reflection. And you also have some kind of functional programming support with predicates and functions. This makes sense if you're still stuck using JDK 6 or JDK 7. But if you already jumped to JDK 8, or if you are brave enough to go with JDK 9, then you can use already very, very good support for functional programming in the Java platform. If by any chance Juice is not your cup of tea and you would like to use something else, then of course we have access to Spring. Now in this case, I would like to talk just about the core framework. There are a lot of projects in the Spring portfolio, and all of them stem from the core, from this particular one, the original one, which will also give you access to JSR 330 behavior. But it gives you a bit more. It gives you more than just dependency injection. It gives you assertions and serialization support, JDBC, JPA, testing, JMX, and so many other things. And this is just also in a small package. And at the very least, if you are already using a Spring, it would be a good thing to just peruse the set of APIs that come in core, and you'll find some special nuggets. So, for example, the message sources and the message formats coming from the Spring, they are actually thread safe, whereas the one coming from the standard JDK, they are not. Okay, so now let's start reducing boilerplate code. And the next program that I'm going to show you, the There is no easy way that I can say this. This is a project that will polarize the community. You either love the project or you completely hate it and you want to stay away from this. And this is Project Lombok. Because what we want to do is when we're going to map the JSON objects to Java, and because we may be using use or Spring, then it's very likely that we want or we need to build POJO objects, plain Java objects. And if we build plain Java objects, then we know we have to follow the Java beans convention, which is something like when you define a property, it has to have a getter and a setter. If it's a mutable property, it has to have a field, a private field. You have to somehow relate to that field in an equals and hash code method. And you probably want to have a toString method, and you might want to have a constructor that initializes the field in case if it's an immutable POJO or not. So there's a series of rules that you have to follow. But you have to follow these by hand. And I know that you can instruct your IDE to generate the boilerplate code using macros or some other kind of template mechanism. The problem what I see with source generated, with code generated this way, is that it is machine generated following certain rules. But once it's generated, you are now in charge of maintaining that code. It is still okay within your IDE to rename a property or to move it to a different class. But when we do that, when you start to move a property to another class, then what's happened with the equals and hash code method? You still have to do something by hand. There's no easy refactoring for that. And then what happens is you want to remove a property. You have to do all changes by hand. And this, again, this is something that was created out of thin air based on conventions, but now you still have to maintain it. The advantage with Lombok is that you still get those getters and setters and all those conventions that we know by heart. But they get added at compile time, and they get added to the bytecode. And your source code remains small. So what we're seeing here in this screen is a repository POJO that has 4 properties: name, description, full name, and HTML URL. And with just annotating this with the add data annotation, this will generate a constructor. This will generate getters and setters, an equals and hash code method, and a toString method for us. Our class could be just these 5 lines of code, just the class definition of the properties, and that would be a full-blown POJO and a well-behaved one. We're also using another project called JSON, which is the one that is going to allow us to do the mapping within JSON and Java. And remember that I said something about the camel case convention and the snake case convention. So we're making use of another annotation from Lombok called @setter on the property full name and HTML URL. And I know that it looks a little bit weird to see that syntax, but that what it's going to do is when the setter is generated, it will put the JSON property annotation on the setter method. So it will be as if you wrote everything yourself. We also put the @JSON_ignore properties at the class level, because you remember that I told you that a repository has like 40 properties or more, but we only care about these 4. If that annotation that we see there, JSON_ignore properties with ignore unknown equals true, were not there, when Jackson tries to map a repository that has a lot of information, but our matching Java class has less properties, we will get a runtime exception. With this setting, it doesn't matter if the repository has 40 or 100 properties. As long as we can find the 4 properties that we're interested, then everything is fine. The next option that we see is that if you're building immutable objects, at some point you would like to have, we usually build immutable objects based on mutable ones, and we follow the builder pattern, which can also be very elaborate and it also follows certain conventions. But if you use Lombok and the @builder annotation is as easy as this. You annotate a static method. The name of the method could be anything you want to. You take as an argument every single parameter that you want to build. So a builder method may have, I don't know, like 10 properties. If your immutable object has 10 fields, in this case, we only have 4. You manually create the object inside this method and then return it. But then, when you actually want to use this actually will generate a new builder class, and every property will have a with method. So for example, it will have a with name, and with full name, and with description. And at the end, it will also have a build method. And this is the one that actually creates the actual instance that you want. And you could have a POJO in an immutable way, or you can have it immutable in this way that I just had it. So it's up to you. It's just, the point is, creating a builder is quite simple if you use the add builder annotation from Lombok. You could use that. Yes.
Does the app builder have to live on the same class that you're creating? So does this have to live in a class, like a class called repository? Or do you live on a...
I believe so. I believe that if you want to do the follow the most conventions that you want, then the static method has to be on the repository class. If you can also have additional parameters on the builder annotation stating what will be the name of the method. By default, is builder. That gives you access to the builder instance, but you could name it something else. You can also change the name of the build method to be something else, like create or make or something else. And I believe you can also state that if you want with as a prefix, or you want to skip it, and a few other settings.
And just on this previous slide, with the setter, the on method annotation, the setter on method, and is that __, is that actually syntactically valid Java, or is that something that Lombok goes in and...
This is syntactic Java, and that's actually 2 underscores. And that's a good question, because we know since Java 8, underscore is not a valid identifier anymore.
Yeah, a double underscore.
But this is a double underscore, yeah. And there's another thing, because this add setter annotation will generate a setter for you, but the add data annotation will also try to generate the setter. But Lombok is smart enough to figure out if there is something already in source that might be generated by a Lombok annotation, they will not be overridden. That means if you manually write your own setter for name, then Lombok will not try to generate it. This add setter annotation will take precedence over the add data annotation. So the custom setter with the JSON add property annotation will be there before add data tries to add the setter for that particular property. So everything works out pretty good.
Yeah, okay.
Right.
And do any IDEs for refactoring, like, are they aware when you try to do refactorings on Lombok?
Yeah, so there is good IDE support for the major IDEs. There's a plugin for IntelliJ, there's a plugin for Eclipse, and I believe that there's, I'm not so sure there's a plugin for NetBeans, and because I believe it also works directly with Java-C. Why do you need a plugin? Because of course the new methods and the new classes, in case that they happen, will only be available at compile time. But you need to know if that information is available at source time. Otherwise, you won't be able to see code completion. So this is what the plugins give you. This is the bridge within the compile time and the source time.
Yeah, great.
Right. Now, Lombok allows you to reduce the boilerplate code. It doesn't generate source code. It generates bytecode. It relies on the APT processing tool, the annotation processing tool, which means if you're using NetBeans, there's nothing that you need to do. APT just works. It can discover processors on the class path. It's done. If you're using IntelliJ, you need to click a list, activate one option in the preferences to make sure that annotation processing is enabled. And by default, annotation processing in IntelliJ will discover processors available on the class path. You can also specify them by hand if you want. And if you're using Eclipse, I'm afraid that it's not enough to tick that option to enable annotation processing. You have to manually find all the jars that provide the processors. Now, setting up in Lombok in Eclipse is easy because the Lombok jar comes with an Eclipse plugin, some kind of hook that you just double-click on it. You double-click on the Lombok jar, and we'll try to find your Eclipse installation and do the right setting for your project. So at least it tries to make it a little much more friendly than that. Now, Lombok will modify the existing bytecode, and this is why some people don't like it, because they feel that it's risky. And it might be so. But if you confine yourself to just a small set of annotations, so as add data, add setter, there's add getter, add builder, equals and hash code, require args constructor, I believe, and toString. These are the ones that control if you want to generate an immutable or mutable POJO or builders. These are perfectly fine. But But if you want to use something else like a sneaky throws that transforms check exception into a runtime one, or some of the things that I will definitely not recommend you to look into these areas. Those are definitely the scary ones. And you don't have to build the most of the transformations because they are done already for you. If, again, you're using well-behaved POJOs, data will be most of the time everything that you have to apply to your code, and that's it. And definitely do not forget to enable annotation processing in your IDE and you happen to use Eclipse or IntelliJ. Otherwise, you will have been a bad time. Okay, so let's look into behavior. And when we are building an application, sometimes we like to have some kind of X-ray mechanism to figure out what's going on. And the quickest way, and this is something that everybody of us has done at some point in our career, is to literal our code using printout statements. And that kind of works. But there are a little bit of better solutions for that. And let me tell you right now that if we're talking about logging, there is no good logging framework for Java. Simply, there isn't. But of all the options that we found out there, SLF4j and Log4j2, do not confuse it with Log4j1, Log4j2 and SLF4j are the ones that gives you the best capabilities despite of all the problems that they make. They also come, there's a lot of baggage. There are two advantages coming from these two frameworks. One is that if you have a big application with lots of dependencies, it's very likely that each one of these dependencies have their own login dependency, which may be different from one another. So you may end up with an application that from one side has Java UT login, which comes from the JDK, but also you have consuming stuff from Apache, which requires Apache Commons login, or it's Apache Log4j or something else. Now, somehow, we have to make sense of all these different logins, frameworks, and configure them in just one place. And this is exactly what SLF4j and Log4j2 allow you to do. It says they have a way to funnel the API calls of all these disparate, different logging frameworks into one place, and that would be just the SLF4j API or Log4j in the other case. The other thing that we do when we start to sprinkle our code with login statements is, for example, log.info and some message. If the message is a simple string, then there's not so much of a problem if that string is discarded if the info level is not enabled. But if computing the string requires concatenation or, I don't know, some other kind of stuff that is a little bit more elaborate, and if that string is not used, is discarded, then we're going to make our application run slower. In order to avoid this, we have to add if guards to our login statements, checking if the login is enabled. But now our code looks uglier. If we use the var_args methods for the different login levels, then this is no longer a problem. Because now you can define the string that looks like a template. It actually uses the message format from the JDK. And then the rest of the arguments will be the parameters I'm going to set on the format. And internally, this login statement will do the check for you. And if it's enabled, then we'll construct the actual string and then invoke the actual login statement. If the login level is not enabled, then we didn't pay a lot of price constructing an expensive string because it was never, it didn't have to do that. All right. So now let's switch gears, and we know that we had to issue an HTTP call somehow because we're dealing with a REST API. Now, there are many HTTP clients out there, and there are many ways that we can do REST, but basically there's only actually one way to do REST. It's just one set of verbs that we need to use, and there's each one of them works in a specific way, and if we follow the recipe, then there's nothing else to be done. Now, there are many clients out there, but I would suggest to have a look at OK HTTP. It's a small project. It doesn't have any external dependencies, not even login dependencies. It has a very small memory footprint because the company that built this is Square. You may know this from the online payments on your phones, on your smartphones. they build Android applications as well. So they need their APIs and their applications to be as small as possible. OK, HTTP is very easy to use. You create a client, then create a request object. They also like to use the builder pattern. These builders are created by hand. They are not created using Lombok. Then you issue a call, and then finally you get a response. Another response you can query for the headers, if the status message, the status code, and most importantly, perhaps for the body. Now, there's another interesting thing about HTTP, is that it supports basic HTTP and HTTP2. So if you have switched already to having your server calls built on top of HTTP2, and you need a client, a Java-based client, to talk to these servers, then OKHTTP will be the client that you must use. OKHTTP is extensible via factory classes, and we'll see that in just a moment. And the HTTP lifecycle can be decorated via interceptor. That means that adding authentication to an OKHTTP client is very, very easy. You can spoof, or you can snoop into the headers from any incoming request, outgoing requests actually, or any incoming responses. Okay, but we are Java developers. Dealing with HTTP is very low level. It would be much better if we can simply say, hey, here's the name of the repository. I want to consume a list of objects. Instead of, hey, this is an URL. Try to parse that into some kind of, here's a pattern for an URL. Here's also the name of the organization. Try to construct a request object, and then we get a response. And if it's successful, then somehow we do the transformation from JSON to Java. That is very, very low level. There should be a much easier way to do this. And for that, the project that I suggest to have a look at is called Retrofit, also from the Square company. Now, what Retrofit promises you is that you define your contract using just Java types. For example, like an interface. The GitHub API that we saw earlier. Now we have two methods here. One of them using an annotation from Retrofit is called add_get, when you pass a pattern for an URL. And notice that there is an argument for this method, and the name matches the kind of placeholder that we got in the URL. And then we got another method annotated with add_get that receives an URL. And this second method is the one that is going to be used to query for the secondary or the tertiary or any other pages that you may have if this is a paginated result. Notice that the return type of these methods is some kind of call object. This is an abstraction from Retrofit, but it has as a generic a list of repositories. These are the actual objects that we want to deal with. So it's one thing to define the contract. Another thing is to say how we're going to use the contract. Using the contract requires some kind of HTTP client. In order to create the HTTP client, we use the Retrofit builder, where you can configure it what will be the base URL for this particular client. You can customize this. You can parameterize this in any way. Now we're making use of a factory. This factory, it relies on JSON. So JSON is the one that is the thing that we're going to use to map from JSON to Java. So this will be now some kind of client factory. Retrofit is a client factory. And use that client factory to create an actual client. This is an actual HTTP client that's going to be wrapped around with the interface that we define it, which is the GitHub API class. And then the last line we see there is just how we would regularly make use of this client. This actually is a Retrofit builder, actually called the client factory. It creates a Java-Lang reflect proxy around an HTTP client, and the wraps it around with the GitHub API. And if you're wondering, well, I just mentioned that Square created OKHTTP. It also does Retrofit. Does Retrofit rely on OKHTTP? Yes, it does. So any Retrofit enabled client will also be able to consume HTTP2 endpoints. So basically, we have Retrofit that can wrap any REST code just using Java code. So no longer do you have to deal with the complexities of low-level HTTP requests and responses, but you have a much higher level. It is extensible via factories and also relies on OKHDB. Okay. How are we doing so far?
Good. Any questions? By the way, if you feel like getting some pizza, there's some pizza on the link, so we can get up here. The question at the back.
Yeah, I have a question about Bob. It says some of the annotations can be checked. What makes them dangerous compared to some of those?
Did you hear that question?
I hear something about annotations, but I couldn't get most of the stuff of what was said. Sorry.
That's right. The question was regarding Lombok and its use of checked and unchecked exceptions. You did mention something about using those would be quite dangerous. So the question was around, what is? Talk a little bit more about that and what's the actual danger in there.
Okay, so the danger is depends on where you are located in the static versus dynamic dispute. If you like a static code and you like static type checking, then you will probably be more comfortable with having check exceptions. But if you like dynamic code, then you will probably like to have exceptions to be more like a runtime exception. So in my case, I love the Groovy code, and every exception in Groovy is a runtime exception by default, even those that are check exceptions in Java. So what is perhaps the warning is, and it might be a harmful thing, is that if you want to go more into the dynamic way, but your teammates like to be on the static way, they might not like that the code suddenly starts to throw exceptions at runtime that should have been caught at compile time. If that does make sense.
So the actual injected bytecodes of the pages per se is more just about behavior, is that right?
Yeah. So basically, the sneaky throws doesn't change the behavior itself of the exception. It just wraps it around with another kind of exception, and it does some kind of trickery with the bytecode, so that, for example, an IO exception, which we know is checked, could be suddenly ignored by the rest of your code. And you only catch it if you really want to do it, but not because you are forced to.
Thanks.
Okay, good. Keep those questions coming. All right, so remember that we built a desktop application, and we have to deal with concurrency. And everything that is, remember, everything that is UI must be in one thread, everything that is not must be in any other thread that is not the UI. Now, in the web world, we have an answer for this. We have an answer for doing or issuing background tasks and then reacting to the result of the execution, whether the result is the one that we expected or the result is something like an error. And in the web world, we call this promises. In Java, we also have the concept of promises, and there is this project called JDFA. And here we got the type that we showed you earlier in red against the promise. In JDFA, a promise can have 3 generic types. The first type is the return value, so we expect this to be a collection of repository objects. The second generic type is a type of errors or failures that we might get. It is not limited to be throwable. It could be a string. It could be any type that makes sense for you to send as a failure. And the last generic type is that at sometimes where you're running a background task, you would like to notify whoever is listening that there is some progress going on. Maybe you say, oh, I'm 10% of this task is done, and maybe it's 50%, 70%, or you're calculating a list of objects, and here's the current list, the current element in such index. So that third type will be the progress. And in this particular definition, we do not publish any progress, so I'm setting both. But in other versions of the code that you'll see in the repository, I'm actually sending some progresses, so the code will be different. So we have to do 2 things with a promise. First is the definition itself, how we create or instantiate a promise. And second is how we consume it. We're going to see the producer first. and it's right here. The method repositories takes an argument and returns a promises with the three generic values that we saw earlier. We're making use of the defer manager object. This is another type coming from JDefer. This is basically an abstraction over an executor service that knows how to submit background tasks. The when method, the content of the when method is a Lambda expression, and this is the background task that we want to issue. The API object is a retrofit client. So we get a response object. If it's successful, they will return the body. By this time, Jackson should have kicked in, does the translation from JSON to Java, so we get a list of objects. And if the response is not successful, then you simply throw out an exception with whatever message we want, in this case, some message coming from the response. And this is basically it. This is the background task that is going to be abstracted into a promise. Now, we're going to see the consumer. This will be the code inside the controller. This version does have some intermediate values. So we got the third time, instead of being void, is repository. Well, we still get a promise. And then the last lines, these are the interesting ones. So the first one says progress, and we use a method reference. So every time that the background task says, oh, I just processed a new repository object, here's my current progress. What's going to happen is going to add it to a list on the model object. If by any reason the network call fails because the server isn't available, because the network is down, or there's an internal error, or there's something happened during the marshalling within JSON and Java, then what we're going to do right now is just print to the stack trace. And regardless of there is a success or there is an error, we want to always change a state. This is the state that controls if the blue button was enabled or not, or if the cancel button was enabled or not. Notice that we also changed the state at the beginning, and at the end, we also change it back to something else. So JDefer delivers you the concept of promises. Promises can be changed. So when you get a result, whether it's an exception or an expected result, then you can do more and more and more with that thing. It is Java 8 friendly. You can use Lambda expressions. It's also Groovy and Scala friendly. So it's pretty much very friendly with other JVM languages. And but it is only usable, it's only good if what you want to do is a one-shot execution. That means you expect to calculate a result, and once you get it, you work with that. There are other ways to do to navigate with REST APIs, and you probably have heard of reactive programming. When instead of producing one value over time, we actually produce a series of values over time. And the abstraction that we use is called streams or events. But this is basically nothing new. Reactive programming is, what I will say, is the same thing they used to do with Swing, with property chain listener and property chain events, pretty much the same thing. But we didn't think in concept of streams. Now we got something that it produces values over time. So for reactive programming, there are a series of projects out there, and probably the one that is most well known right now is RxJava. There are two versions, RxJava 1 and RxJava 2. And what is the difference? RxJava 2 has an object, a type called flowable, that gives you the concept of back pressure. Whereas RxJava 1 has an object, a type called observable, that kind of has back pressure, but it actually doesn't. So what is back pressure? If your producer is producing data very, very fast, or your consumer is slower than the producer, then it's very likely that the client is going to get bogged down. Your consumer will die probably because of there's so much data coming into the pipeline. With back pressure, the consumer can give hints to the producer to slow down or to buffer the data, to give time to the consumer to finish the current batch and then be able to handle the next one. So you could interchangeably, perhaps in RxJava 2, use observable, flowable. In this particular case, I don't define anything that is related to back pressure, so I'm just using observable. And in observable, what we do is that we decorate through operations. So the first thing that we see here is the call to the repositories method gives us back an observable of as just a repository. It's not a list of repositories. So we expect repository instances to come as they appear through time. And then we have an operation called take on observable, and we assign it back to the same reference that we saw before. That is because every operation on observable decorates the existing observable, so that at this point in time, we actually could have pointers to two different observables where we're going to override the same instance. And then we continue to do some operations, for example, a timeout. If the network call takes more than 10 seconds, then we go into abort. When we subscribe, that is when we start listening to events, then we change the state. When we terminate, regardless of a success or failure, we're going to change the state again. We subscribe on a background scheduler, that's I/O, or it could be a different kind of scheduler. If we didn't, the observable will be consumed on the same thread as the current component. In this case, will be the UI thread, and that will be bad. When we subscribe, there are many ways to subscribe, but in this version, we say the first is the expected result, or as results come in, that will be a repository element per invocation. So we're going to simply add it to a list. And if there happens to be an error, we just simply print it to a stack trace. So this is exactly the same behavior that we saw before with JDFF, but in this case, we are reacting to when repository instances, each one of them, it's passed by the retrofit client and give it to us. And you may be wondering, is it possible to use retrofit and RxJava together? Yes, it is. So first, we have to update our contracts. So that instead of returning call of list repository, we return an observable, or it could be a flowable, of a response, which is from retrofit and list of repositories. And that's basically it. On the retrofit client factory, we just need to add one more adapter factory right there, which is the RxJava call adapter factory. And then we create the proxy as before. We just need to configure one single factory, and that's it. Isn't that great? It's just simple. Here's a number. Sorry. You were saying something?
Oh, just appreciating. Yeah, looks pretty good. I do have a question. Does retrofit manage its own pool of connections?
If it makes a pool of connections, that will have to deal actually how you configure the OKHTTP client. Because there is a way here, I didn't show it, but as part of the methods that you set here in the retrofit builder, you can supply an already built OKHTTP client with all the settings that you want. So if OKHTTP supports some kind of connection pooling, then you have to set up on the outside and then supply it to this retrofit builder.
Yeah. And with the defaults that you just showed on your slides, what kind of scaling did you achieve? You ever tested how many concurrent users, like how many, I guess, through Rx, how much flow you can get through an observable pipeline?
Well, we have to take into account that OKHTTP and HTTP2. If you consume an HTTP2, then the connection will be multiplexed already. If it's not, if you're talking to base HTTP1, then you want to grow this, you want to scale this, you might need to create multiple clients, and then your limit might be, the first one would be the memory.
Yeah, that's a good.
Yeah.
Excellent. Thank you.
Okay. Now, here the following thing that I'm going to show is how you can handle multiple pages, how we make use of these two method calls that we have defined here, the one that takes the first page and the one that takes the second page. And pretty much what we want to do is issue one method or the other, and we want to combine them, returning just a single observable repositories. And we have to understand that each page actually returns a list of repositories. And somehow we have to flatten the structure because it's not a list of repositories, but just an observable of repositories that we need to return. So what we want to do is apply different operations on the observable. And here we see somewhere items.flatMap. And then we see somewhere here the current page, this returns this is an observable, and we concatenate that with a recursive call of the same thing. So basically, this is a recursive call for each subsequent page. The first one is handled here, and then this code recursively will handle any of the pages, concatenating the result of the next page until we finish, and everything will result into a single observable T. In this case, we know the observable T will be repository, just because we applied FlatMap. And this is the beauty of RxJava and Project Reactor as well, that they provide you a lot of operations that are quite rich so that you can work with your different observables. The advantages of RxJava is that it implements the observable pattern, is well known. It has a lot of operations like zip and reduce and flatmap, concat, and so on. And you will find the same operations in Project Reactor. Actually, the API within Reactor and RxJava is quite similar to one another. If you switch from one project to the other, it's just a tiny few changes that you need to do, and then you're off to go. And of course, it also supports back pressure, which is quite important in some scenarios. Finally, component communication. And we are ready to jump into testing after this one. Sometimes we want to build components that want to communicate to one another, but between them, they don't have a direct access. So we're not using dependency injection between them. So the best way to do this is to have some kind of publishing subscribe mechanism. And one of the ways that we can have this is through a lightweight event bus. For example, the one that I'm showing here is called Ambassador. This is the code that we saw earlier with RxJava. And instead of throwing an exception when or print it to the stack trace when an exception occurs, what we're going to do is just publish an event through the event bus. We're using publish async. That means we're going to fire and forget. The same thing as saying post. You also have the option to say publish. This is a send. This is a synchronous event. That means the consumers have to finish doing everything they need to do with the event before the producer can continue. And the troll event is one of the classes that we saw earlier with Lombard, which is saying that it actually creates the argument with the matching element. So this is how we are consuming. Now, this is how we produce an event. How we consume the event, we can do it something like this. It could be any class. The important thing is that we register ourselves with the event bus, so we use a dependency injection. We use post construct that pre-destroy, so we know that our dependency injection container can have a life cycle for managing our beans. In this case, post construct, after everything has been set up, then we're going to register ourselves with event bus. And when the dependency injection container shuts down or says this instance can be discarded, you should invoke pre-destroy. So we disconnect ourselves from the event bus. We unsubscribe, so there are no memory leaks. So that's fine. This is just us being good citizens. The important thing is the last method you see here. It has an annotation called addHandler from Ambassador. The name of the method could be anything you want to. The modifier, the visibility modifier of the method could be also anything you want to. In this case, it could be public, could be private. The important second thing of this method is the argument type. This is the time of event that you would like to handle. And then inside this method, you do whatever you want. In the repository code that you will see, there's an application event like this, an event handler, that reads the information, the stack trace from the throw that was sent, and pop-ups a dialog stating, well, this is what happened. Do you want to do something else or not? It could be anything you want. You probably want to log it, journal it, send it to a database, do something else. It's up to you. Now, Ambassador is quite good. It's configurable via annotations. It's a much faster and better implementation than the Guava's event bus. Actually, there's a link that has a benchmark, a comparison between the two different event buses and a few other more. But Ambassador is not so much actively maintained by its author. It still has some releases in the past few months, but if you encounter a problem, then the author might not be as quick a response or give you a reply as you expect. Now, this being said, we've been using Ambassador in production with a couple of customers, and most of our customers are pretty much financial institutions in Switzerland. And these things are actually work. There is no money lost here. So this thing is quite production ready. Okay, so this ends up the section with production code. Do you have any questions regarding your production, or we can jump directly into testing?
One question left. Does Ambassador work with Java 9?
Does Ambassador work with Java 9? It should, and that's a good question because Lombok doesn't. The last time that I tried to compile Lombok and Java 9, I got some trouble. But Ambassador shouldn't have any problems.
Any other questions? No, please continue.
Okay, all right. So I would suspect that most of you are familiar with JUnit 4. And probably some of you have already tested JUnit 5 that was released in September. And if you haven't, and you have given a try to parameterizing testing, I know this is not so common, but if you have, then you know that parameterizing testing in JUnit 4 is not really that good. And it could be much, much better. And there is a project out there called JUnit Params that gives you better capabilities. For one, you can define the test values directly using an annotation called parameters right there, just an array of values. Or you can define the method name of the data provider, or you can define a class name that functions as the data provider, so you can reuse this data provider across different testing methods. The problem with the JUnit 4 parameterization is that the test case itself captures a state. That means that every single method that you parameterize in the same test case must have the same number of arguments in the same order with the same types. Whereas with JUnit params, depending on your scenarios, you may want to have two different methods that have every different kind of combinations for your parameterization that is completely different from one another. There is one more thing that you need to be aware of, is that JUnit params requires a custom runner. So if you're already using a runner in your test case and you want to parameterize it, then you won't be able to use JUnit params. You might need to use something else, and that something else will come up shortly. The next one is because we're using dependency injection, we want to have our class on the test to be tested completely in separation or isolation from any other collaborators. And for that, most of the people use some kind of mocking solution, and Mockito is the best one out there. You can combine it with JUnit params, as I'm showing right here. This is another kind of code. The class under test is a controller. We're passing two collaborators, the model, which is a simple POJO, so there's no need to fake it. There's no need to mock it or stop it. But the sample service is a mock. Then we define our expectations. We say when the service say hello method is called with specific input, then we return a specific output. It's a cant result. Then we invoke the stimuli, and then we do some assertions where the controller did the right thing, the model was modified as expected. But we also verify that the mock was invoked only once with that particular method, with that particular input. If the say hello method is invoked more than once or never, or if it's invoked exactly once but with a different input, then our test method will fail, because it's very likely that the controller did something that was not what we were under our expectations. You can think of Mockito like a static DSL for defining mocking and stopping and even the spice. It is quite good. You can mock interfaces, abstract classes, concrete classes, and believe it or not, you can also mock out or stuff out final classes. Then we also get Juquito. Juquito is a combination of JUnit, Juice, and Mockito. So if you're already using Juice in your projects for production, then you can use Juquito for testing. The advantage of Juquito, it also has a custom runner. You can do injections on your test cases, like injecting the controller here. This will come from the dependency injection container. If you have a binding that is not defined, for example, the service, that this binding is going to be mocked out with Mockito automatically. And that mock, in the case of the controller, will be injected because the controller defines a dependency to a sample service. So if you happen to have an integration test case or even a functional test case, then you can reuse the same mock in different places if it is needed. And the dependency injection container will do everything for you. You just need to state the bindings as you would do in production. And once you do that, then we can test out the things. You notice that in the setup here, we do the expectations on the mock, as we saw before, with concrete values now. In the actual test method, just a regular test method, and we do the same thing with the verify. We're verifying the mock that was created by Juquito for us. And that's basically it. If you are keen of broadening your horizons to try different JVM languages, then you can give it a try to Spark. Spark is a testing framework written in Groovy. Where you're seeing right now is Groovy code. It is the same behavior as before. But there are some interesting things going on. First, what about that method name? Is there something interesting about that method name? Other than the fact that it's a string. And it's quite cool. Because I don't know if you know, but the JVM is the one that allows you to use any kind of character for an identifier. Java, the language, is the one that restricted to a certain set of characters. Groovy and Spark gives you back the full capabilities of the JVM. So what this method name is going to do is actually score in a very descriptive way to say, well, we expect some inputs, there's going to be some output, and that hash input and hash output, things that we see there are actually placeholder for real values. And these values will come up from parameterization. Now let's look at the different blocks we have here, given, when, then, where. These blocks have a special meaning. In the given block is when we set up our test under our class under test. We could also set our mocks. Here you see that we are setting a mock for the service using something that looks like a Lambda expression. You haven't seen Groovy code. It's quite similar to Java 8 now. That's not a Lambda expression. That is a Groovy closure, but it's kind of like the same thing now. Then in the when block is where we execute the stimuli. You see controller.model.input equals input. That is actually a setter call, but in Groovy you had property access. So getters and setters use a shorter notation, but it actually invokes the real setter and the real getter method. Then in the then block is when we do the assertions. The output, we expect it to be a string. Controller.model.output, that will be controller get model, get output, and that we expect that to be a string. Is that the way that we compare strings in Java? No, right? It isn't. But we will love that it will be the case. Well, Groovy has operator overloading. And the equals method operator actually invokes the equals method for you. So this, as you look into the bytecode, this actually does the right thing for you. And in the then block, we got implicit assertions. You don't have to use assert equals or assert true or the assert keyword. It just happens. And in the where block is where we do the parameterization. There's one way to do parameterization. We're pushing values. You can think of this is the right shift. No, this is a left shift operator. And we're pushing each one of the elements in the list, because that's in Groovy you have native syntax for collections. So this is a list with two strings, and each value, each element of this list is going to be pushed as the value of the input variable, and in the other case also will be the input, the values for the output variable. And now we know the values that are going to be substituted in the references that we saw in the method. And if you use the unroll annotation that we see at the top, there will be two methods, generated in bytecode instead of just one. And each one of the methods will have the actual value substituted for input and output. If this will work in the IDE, this works in Eclipse, in IntelliJ, and in NetBeans. You will see two different methods, much better than the alternatives. It's basically a Groovy-based DSL for testing. You can parameterize multiple methods. You can parameterize test method names. It is JUnit friendly, so you can consume existing JUnit extensions such as, well, you can use Mockito if you want to. You can use HTTP unit and PDF unit, any kind of div unit actually with a Spock, and it will work marvelously without any problems. There is an extension project out there called JUnit to Spock that will allow you to, using a series of templates, predefined templates, to translate or migrate your existing JUnit test cases into Spock specifications. So you don't have to do the work by hand if you want to give Spock a good try. Now, because we're dealing with concurrency, we're going to the last two projects. Because we're dealing with concurrency, we have to wait for conditions to happen. Now, usually, what we do for waiting on a test case to do something is to sprinkle our code with thread.sleep calls or doing some kind of a sleep call on a time unit or something else, right? And the problem with this is that we may be sleeping for too long, and we are making our test cases to be run slower and slower. It would be much, much better if we have a conditional wait for these things to continue or not. So we know for a fact that invoking the controller load method will be invoked running a background thread because we're using RxJava or we're using JDFA. We have to somehow let our test case wait until the controller load method has finished doing its processing so we can do the assertions. Typically, this is where the place we will use a sleep call, but if you use a utility, we can have a conditional state here. So a wait is the static entry point of the utility DSL. We can have a timeout, for example, 2 seconds. If our test case takes more than 2 seconds to finish, then the test case is going to be marked as failure. It's going to be red. But if it takes less than 2 seconds to fill that condition, then it will continue. Now, the condition here, we're using a method reference. You can use a lambda expression, or you can use anonymous inner class, depending on the JDK level that you're using. This is basically a callable. And then we're using a matcher, a handcrest matcher, to figure out if the condition matches or not. Because it uses handcrest, then you can use any kind of handcrest matcher. You can create your own matchers. There are extensions for utility that are friendly to Java 8, so you can use method reference and lambdas. You can use Groovy functions. You can use Scala functions. I'm not so sure yet if they support functions from Kotlin, but yeah, the kind of support shouldn't be far away, given that Kotlin is rising in popularity. And as I said before, you can customize the conditions using any kind of handcrest matcher. And then finally, and I'm going to go back to the terminal. And if we wanted to run a full functional test case, that means we have to have some server running. And if we hit the actual GitHub server, that will be kind of bad, because there is a rate limit over the amount of calls that we can invoke at a certain period of time. But also, we don't know if the GitHub server is available, or it could be in a state that is not the one that we need for our test case. Replicating the GitHub server locally is also quite a daunting task. And even if we did, we have to set it up in a specific state for every test case. So we could set up we can run the server as part of a build, but that's still a bit of a problem. It would be much better if we were able to run the server in process inside the test case. And that's exactly what I'm going to do here. I'm going to run every test case I have defined for this project. At some point, you're going to see a window popping up and the buttons going wild. And believe me, this is not me doing by hands. Everything is done automatically through a project called TestFX, which is kind of like Selenium for JavaFX. Oh, no, sorry, they run. I should done tests. So GW test, and this should run the test cases. Let's do a clean just in case. And this will run unit test, integration test, and eventually a functional test. And this functional test is hitting a fake server. There we go. Here's the UI, and it's doing very quickly, so you can tell that I'm not doing this by hand. There's the error popping up by the ambassador that I was expecting. Everything is working fine. What's going on? If I show you the code, and I go into the tests, go into functional test, I'm gonna make the other code a little bit bigger. Don't worry about that. Bigger. There we go. Here I have a functional test case. The important thing is this piece of code. We got a JUnit rules as a kind of extension for JUnit full, and a project called wiremark. And a wiremark rule which will set up a fake HTTP server on port 8080. And then we set up our expectations for wiremark. It says, if I get a GET call that matches this URL pattern, I'm going to reply with a status 200, JSON payload, sending some headers, and then this is some kind of factory that I have in the code that will transform Java objects into JSON, again using Jackson. And if you get another GET call with this particular URL, then you reply with something else. You could do something like the cancel path here. And I believe there is another one that says failure. For example, even if you get a right URL call like this, I want to reply with a status 500 saying, no, go away. There's some internal project problem with our server. There you go. So basically, this is what a wiremark allows you to do, is create a fake server. You define expectations of the matching request, and there is a match. Then the response that you have configured will be sent to your client. And if there's not a match, then wiremark, the rule will automatically say at the end of the execution of the message will tell you, well, guess what? You defined 2 requests, and there was just a match for the first one, but not for the second one. So your test actually results in a failure. It's basically a DSL for matching HTTP requests. It supports also record and playback. So it's an overall quite good option or solution for you to test out clients without having to write a full-blown server. And that pretty much works in the same idea as Mockito and the other faking source code or behavior libraries that you have seen in the past. So yeah, this is nice. I guess all the libraries that we saw right now, but what about Vertex? What about Netty and gRPC and so many things? What about your Firewall library that you may be already used to working with in your projects? Well, yeah, I could probably talk about more different libraries. And as a matter of fact, if you look at the repository and the link that you have the links to the slides as well, you will see there are other libraries and there are other projects in this repository that I will try to showcase as well. But, well, given that we have at most 2 hours right now, I guess this is as much as I can spend on the current set of libraries. But if you would like to see more information, then just please get in touch with me and we'll see what happens. We'll see what we can do. Remember, everything that we saw today is open source. And you too can also contribute to open source. The easiest way for you to contribute to open source is that if you find a problem with any of these projects or any other open source dependency that you're consuming, then please report a ticket, file a ticket. That is the easiest way. Let the people at the other side of the wire know that you are using the project and you encounter a problem. Or perhaps you want to submit a feature. If you do, when you submit a ticket, please give as much information as you can. What is your operating system? Which versions are you using? Which JDK version? The steps to reproduce, just as you regularly do with any other ticketing system. And that will start the conversation. If you have the passion, if you have the time and the skills and everything else to make it happen for creating a test case or even submitting a patch, then please do so. But at the very least, try to submit a ticket if you find a problem. If you want to know more about the stuff that we saw today or any other kind of topic that follows in the same vein, I have a newsletter in English, and the second link is the same content but in Spanish. And I have a few issues already out. I will try to put out content every month. If you have, again, ideas of things that we'd like to see covered, just like get in touch, and we'll see what can be done. So for that, thank you very much for your time. I hope that I was able to get some of you excited about these projects. If you have any questions, well, just let me know.
Do we have any questions? Did anybody learn anything new? Yes, we got half the hands up. Everyone else knew all the, who hasn't seen a library yet? Who's like, found a new library? Just about everyone. Yes, right. And other people's arms aren't moving. Excellent. All right. Thank you very much, Andres. I think, yeah, there's no other questions. So I know it's quite late. Really appreciate you. Oh, the one? All right.
Yeah, that's one over there.
Yeah, so the questions about Lombok and the use of the camel case. So in the Lombok slide, there was the Jackson. We were basically saying that Jackson already supports converting camel case. It's not a Lombok feature.
Right.
So Lombok would be to fix, or Lombok would be just to create the setter method. Then the extra syntax was there to say, put that Jackson annotation onto that created setup.
Right. Exactly. So you could have written the setter method for that for HTML URL or full name by hand, and place the JSON property on the method itself, and that would have resulted in 3 lines of code. Well, actually 4 lines of code. If you put your braces in the wrong line, then it will be 3. But with using the add setter, then it turns out to be just 2 lines of code, and you don't have to repeat yourself setting the field itself, which is something that Lombok will do for you. Now, but you, in order to do this happen with Lombok, you have to use this weird-looking syntax with the ampersand and double underscore. So you get one from one side is just shorter code, it's a little bit more concise, but you have to decipher a little bit what's going on. Whereas the other is, of course, the exact code that you have written, so you are not winning anything by using Lombok in this case. It's just regular Jackson mapping.
Does that make sense? Any other questions? Well, with that, thank you, Andres. Just another round of applause. We know it's quite late where you are, so I hope you have a nice sleep. And we thank you very much for joining us. And we hope to see you again maybe next year, if not online, then in person at a conference somewhere.
Yeah, hopefully one of these will be in person as well. I've been to Australia once. I'm looking for an opportunity to go back again. So thank you guys, everybody, to being present, for your interest, and keep rocking the Java world. I know that the group has like a couple years now already. Is it?
Yeah, about 5, 6
5 years now. Nice, yeah. Going strong. Excellent. So keep doing this, everybody. You're awesome. Keep rocking the Java.
Thanks a lot.
See ya. Bye-bye.